So hello, everyone. Welcome to the SNOMED CT research webinar. I am Susie Roy, the host of these research webinars. And I am just going to run through a couple of really quick housekeeping notices, just because it's been a little while since we've done one of these research webinars, and also for those who are new. So as you come in, you'll notice that all attendees are muted and your videos are disabled. However, if you have any questions as we go along, go ahead and enter any of those questions or comments into the Q&A box at the bottom of your screen. And at the end of today's presentation, we will be sure to field your questions over to Dr. Shek so that he may answer those. Just as a reminder, this meeting is being recorded, so I will make sure that all of you who have registered will have access to the both the video and also the slides after today's presentation. So as a reminder, this research webinar is part of a whole web series that we provide at SNOMED International. We have clinical webinars and implementation webinars. And of course, I'm very biased to our research webinars where we focus on SNOMED CT research, either with or on the terminology, and featuring a number of highly esteemed researchers within our SNOMED CT community. You can find all of the upcoming research the web series webinars on our snomed.org/web-series page. And also links to previous webinars from the past several years. Speaking of those, if you've missed any of the previous web series, you can go to our SNOMED International YouTube channel. Just go to YouTube and just search for SNOMED International. There you'll find not only our web series videos, but also videos from our past SNOMED expos, as well as a number of other SNOMED CT videos that we've done over the years, highlighting use of SNOMED CT in various member countries and all around the world. If you'd like to be notified of upcoming research related news, you can join our SNOMED CT research reference group. This is essentially a Google group that I just use to provide push notification to all of you. So to join, just email me, Susie, SRO@snomed.org, and I'll get you on that list. And in speaking about the SNOMED CT Expo, so last month we held our annual SNOMED CT business meeting and expo in Lisbon, and it was a really excellent event. Throughout the entire meeting, from the business meeting to the expo, SNOMED research engagement was front and center, all the way from the highest authority with our General Assembly being provided updates on our SNOMED research engagement strategy. And we had, even during the SNOMED Expo, a brand new stream focused solely on SNOMED CT research, where we were able to now, instead of kind of weirdly trying to fit all of our research work in some of the other streams, we now have a stream solely dedicated for our research means. We also had a SNOMED research engagement roundtable, where I was able to not only present highlights and updates of our research focus, but also hear from you on providing input into the next steps for our research engagement strategy. So over the coming weeks, I'll be kind of summarizing the events from the expo and launching into what are our next steps in research engagement, and I look forward to sharing it with the rest of the community. And not to start planning too early or anything, but we have to do that, and we're starting to look at our SNOMED Expo 2023. So go ahead and get the dates, October 26 and 27, into your calendars. We'll be here in the US, where I'm located. We'll be down in Atlanta, Georgia. So get those dates into your calendars, and we'll be sure to inform you as soon as we start having more details on that. And so finally, to the main event for today. So I'd like to introduce Dr. Anthony Shek. He's a senior data engineer based at Guy's and St. Thomas Hospital NHS Foundation Trust. He holds a PhD in clinical neuroscience, and this talk will highlight a success story of using free and open source software to retrospectively structure millions of real world documents with SNOMED CT. So today's talk is entitled Experiences from Automating Hospital-Wide SNOMED CT Extraction. And with that, Anthony, please proceed.
Wonderful, thanks Susie for that introduction. And also thank you for inviting me to talk and present some of the work that we've been doing in London. So while I look to share my screen, although I am primarily based at Guy's and St. Thomas Hospital, I've been doing work with quite a few NHS Foundation trusts as well. So let's just jump straight to it. Oh, how do I go to the next slide? Fantastic. Yeah. Great. So just a bit of background to start off with. In a typical secondary care large NHS hospital, a lot of data is stored in the electronic patient record. And in fact, the majority and everything or all interactions with a patient is generally recorded in the electronic patient record. And so you can imagine a large London hospital, really everything and everyone generates data from patient results, the clinician writing a report about the interaction they had with the patient, and which really contains why the patient has come and what's the issues, and you end up recording a patient history, and this is stored electronically. And I guess there is this is really considered a big data problem, where I guess these famous 4 Vs are the main issue about why a lot of this data can be considered trapped or unlocked. And in fact, there's a lot of potential there for it to be used for furthering insights into, either improving patient care, understanding more about our patients, and our ability to surface that data is absolutely crucial. And I guess a lot of these electronic patient health record systems, irrespective of the provider, have been primarily developed for direct patient care involved, and secondary data analytics have been a slight afterthought in that case. And so the reason for this is because I guess a lot of the majority of clinical information is really held within clinical narratives or the unstructured texts or patient letters, doctor letters, and about the interaction with the patient, and so the patient can read. And it's a lot easier and it's a bit more better at capturing, has the flexibility of capturing everyday sort of conversation or doctor to doctor or patient to doctor communication. However, I guess in the area of medicine, a lot of information that is exchanged, especially of diseases, disorders, all the different medications, really requires some domain expertise just to really understand what is, what does it mean, what exact tests are there, and sometimes letters are written, especially with internal documentations, written quite informally, and a lot of local acronyms or it's almost its own language really is used in a hospital setting. And so just really quickly before I move on to, well, what can we do with, surfacing these data insights? I first want to say that I guess in a hospital, data isn't necessarily stored in one single place. And it's quite, and I'm just saying a bit of background here, and that each department may or may not have their own sort of data silos, which store data in different manners. So, and these can be in a variety of different formats. So for example, each department may have a single database. Some may store it directly in a SQL database, or some contain documents in different file types, or even scanned images as well. And so amongst these hospitals, South London hospitals that I work at, there's a tool called CogStack, which can help to sort of centralize this data and process them in a way which can unlock the contents of the data to make them directly queryable. And so, I'm not going to go too much into depth about this system, but essentially it's a way that one can search through, I guess, a hospital, whichever databases are connected to it, to search for it in one place. And you can also search within the contents of each document. And essentially, this is just forming a data lake from which data analytics and a lot of the tools I'll be talking about next are applied at. And so this is what it sort of looks like. You have a bit of a search bar where you can add certain rule-based terms to surface bits of data as well. But as I said, this is a little bit beyond the scope of what SNOMED CT is interested in. But to set a bit of background, this is just how we form a data lake, because any form of data analytics, well, you need to have access to the data, which is actually one of the hardest problems in data science, getting access and surfacing data. And so a bit of pre-processing occurs in this system. So irrespective of the data format, what CogStack does is helps strips and standardizes each document, so it kind of flattens it. So in the previous search, and so on the page on the left, there is an example of how a patient letter or a doctor letter would look like, or in this case, an A&E report. And on the right-hand side is how it's been stripped of this sort of pre-formatting structure, and it's a bit of a lightweight, flattened text file, which then you can easily go through the free text. And of course, you can then rapidly search through and highlight. In this case, we searched for 2017 and first seizure, and therefore it allows you to query it and surface it. So already enormously powerful to try and surface trapped siloed data around a hospital setting. Great, but even then we have a challenge. We have a challenge, right? And that is the actual contents within the document. And that's predominantly because it is unstructured, meaning there is no standardization requirements. And it's actually within the contents of the document where all the clinically valuable information is held. So in this example, or across a set of or a corpus of documents, you may get a question. And some of these questions or use cases that one would want to know from your data set is, well, does the patient have an epilepsy diagnosis? And in this case, sure, you can search for the word epilepsy in these documents, and that's what we've done, but it's not really ideal. And this is because in this case, this is a client of our epilepsy clinic. And so it's not really, in this case, yes, I mean, they do have epilepsy, we read on further, but it's not the key point that we want to be extracting. Ideally, you would want to, I guess, ignore that first term and have a way to look at all the different epilepsy terms or combinations and different types of diagnosis that relate to epilepsy, and based on the context, then look to extract it as well. And so by context, meaning it's not an epilepsy clinic, or his sister or their sister doesn't have epilepsy. And of course, right now, a lot of this work is done manually, but it's potentially a huge amount of work to be done manually. Because as I said, with a large London hospital, you're looking at scales of millions of documents to potentially answer these questions. And of course, like, although with the advent of technology and word processing tools, it's still very messy. I guess the freedom of having unstructured text is that, for these clinical narratives, is that a clinician or a healthcare professional can write whatever they want. However, the disadvantage is that there is no standardization requirements, and it sometimes and quite often contains spelling mistakes, acronyms, synonyms, incomplete sentences and missing data, and some terms can be ambiguous as well. And so in order to perform any form of downstream analytics, it needs to be structured in a way, and key terms and phrases need to be labeled. And I guess this is what this talk is primarily going to focus on. How do we really do that? And I guess even the past few seminars or SNOMED seminars, and there's really been quite a few fantastic previous ones which have spoken about natural language processing. And I'm just going to continue on from that and I guess build upon the previous SNOMED CT webinars and talk about, obviously give a bit of an introduction first, but talk about how do we actually use these automated methods and how do we leverage the power or the knowledge base that SNOMED holds to automate this process as well, and how it's really wouldn't be as possible to be done without the advantages of SNOMED. But just going back to natural language processing, this is just a field of computer science of how computers process and analyze your natural language or free text information. As I showed before, you can definitely write rule-based rules to extract bits of information. And these are generally like what we did before. You can write spelling mistakes, and regular expression fuzzy matching is can be very powerful, and they're generally quite fast to run and build. However, they can become complex quite quickly, especially when you try to consider all different variations of the word. What happens if it's ambiguous? Like the word fit. This patient is fit and well. This patient with epilepsy has a fit, meaning seizure in that context. And so we're looking to, look to an alternative approach, and I mean, not really just solely an alternative approach, but turn to the field of, I guess, machine learning to help learn a lot of the linguistic patterns without explicitly being told as well. And so, but realistically, in a productionized environment, a combination of the two is used, and that's exactly what we do. And so the specific task that I'm actually talking about, NLP is a large field that contains different areas or topics such as you can do topic modeling, summarization, but today I'm going to talk to you about named entity recognition. And this is essentially where it looks to identify key information from free text. And ideally, what I'm about to show you is a tool that we've created that looks for SNOMED terms in free text. And of course, with talking about these tools, and there's a bunch of, other than the ones I'm going to talk to you about today, there is a huge open source community and ecosystem that is actively developing a variety of these tools. And here's just a list of the most notable ones, but there is plenty more as well. And it's a good place to start. And looking at the way or the speed that AI or the field of AI or machine learning is developing, it's really exponential, and new models, new data sets are really being released, not just every year, but now within every month, something new or a new model or language model is being released. So it's quite hard to keep up with, actually, but very exciting times. But today I want to talk to you about a sort of in-house built tool that we've developed, and it's called MedCat, or the Medical Concept Annotation Tool. And like the previous tools, this tool is also free and open source. And what it looks to do is essentially leverages the SNOMED CT terminology structure to recognize and label free text. Awesome. So I just got there's a bit of a web app demo that you can easily scan, or there'll be links as well provided, so one can test it out itself. But let's just go to a demo page, and this is what it looks like. You can enter any bit of free text, and this is just a demonstration for demonstration purposes only. And whether it's misspellings or variations or combinations, it tries to attach the most appropriate SNOMED code wherever it's found to be appropriate. So in this case, epilepsy, the epilepsy patient is now seizure-free, but it's misspelled, and there is some form of recognition there, and there is a sort of confidence here as well. And of course, using SNOMED CT, there's mappings to ICD-10 and hierarchies as well, which you can then identify which terms are being recognized and how well it's being extracted. Of course, it's not necessarily just a direct match, but in this case, it's understanding that fit means fits. But of course, that's a small example. And of course, when you, as one plays around with it, feel free to enter any bits of text. I've got an example here of a radiological report, and you can obviously enter and just play around and see how well this base model works. And yeah, just a bit of a caveat, this is a base model, and that this is not for production use, irrespective of how good it looks as well. Just to essentially demonstrate its capability. And so here we're showing a named entity recognition where it's demonstrating that, in this case, acute infarct, rather than choosing acute, the word acute, which I'm pretty sure is available in SNOMED, such as down here, it's understanding that these two words are linked together, and this word acute infarct belongs to this semantic tag, morphologic abnormality, and it has a status other. So something I'm going to go into is about these meta annotations or context, where in this case, in the demo model, you'll see a status label. And this can mean either it's affirmed, or they have it, or it's something else and it shouldn't be extracted. And in this case, if you read the context, sure, the model is recognizing acute infarct as acute infarct here. However, it doesn't belong to the patient and it's not affirmed. And so if we go to a different, there is a right MCA, there's a structure of right middle cerebral artery. Over here, this is affirmed. And so just to show that this isn't really any trickery, if I just change the context a little bit, so there is an acute infarct, we can go through and see what is annotated. And over here, it's changed the status as well. Because when you're interested in extracting information, you're not just interested in whether it's present in the document or not. You need to know the context as well in order to accurately extract it. So in this case, with this very basic meta model is what we call it, we'll only extract the affirmed mentions and not things like epilepsy clinic or family history of epilepsy, for example, although you could do if you wanted to. Right, so just going back to the slides, and of course, yeah, there is quite a few demonstrations where you can write any bit of free text, and you can use this tool to actively annotate any portion as well. So whether you deploy it into your front end as well, or you can retrospectively use it to go back and train. But in this case, I want to talk to you about various workflows. First, a little bit about the model itself, and then about the workflows. And if there are any questions about how it works, happy to answer them in the questions below. In this case, there are three sort of meta models where there's experiencer, irrelevant, and certainty. And these sort of meta tags can be completely customizable to how one would like to do it. And I guess in SNOMED CT, one could label it under your qualifier values as well, and train models to attach which type of qualifier value is there. Great. But anyway, feel free to try it out yourself and use it and explore. And for those, I'm not going to go through too much to the components, but if you're watching this on the recording, feel free now to pause and to have a look at the very basic levels of MedCat components and what they are. So I won't spend too much time on this, but if you're on the recording, feel free to pause, and this should help point you to the right directions within the model to help learn about the different components and what they do as well. Fantastic. So the way how it works is, I guess it is, the architecture has been inspired by a technology called Word2Vec. However, this isn't quite Word2Vec, but rather a concept2Vec, where you use SNOMED CT concepts and you represent them with a something we call an embedding or a vector representation. And so with this is essentially a 300-dimensional vector representation, which aims to capture the context. And if all these words and jargon is completely flying over your head, the previous two research webinars do an excellent job about skimming the surface about what they are and what they mean, and there's plenty of tutorials online. But essentially, for all intents and purposes, if you can remember back to high school, I guess algebra and matrices and vectors, from 300 dimensional, you can do a variety of mathematical processes here as well. And so using SNOMED CT and SNOMED CT's hierarchy, semantic tags, and its structure, you can choose certain candidate concepts. And based on the vector representation, you can have a look at, well, which concepts have a similar meaning. And you can do this mathematically because these vector embeddings represent the context in which they are or can be found in. And the idea of or knowledge of what that concept is. And so with hypertensive disease or the concept, you can go through and, if you filter for only medications, well, what are the nearest medications that are associated with this concept? You can do the same thing. And here are different examples or different terminologies where you can filter the most similar and filter it based on your SNOMED CT hierarchies as well. Of course, as well, you can do mathematical processes, additions or extractions. And the previous talk sort of got word to vec, and they used this very famous example based on the original word to vec paper of the king, queen, man, and woman. So king minus man plus woman. Well, what does it represent? It represents a queen, and that was from the original Google paper. And we've just replicated that to a degree, or took inspiration and applied it to your SNOMED CT concepts where, sorry, where kidney failure minus kidney plus heart, well, the nearest concept we demonstrate is heart failure. And the same thing with various drugs and brand names as well. And so you can also have a look at the sort of nearest disorders. And so you can obviously just plot it and reduce these embeddings to from 300, if you consider a vector 300 dimensions, you can reduce it down to your X and Y or two-dimensional vector representation using a, your principal component analysis or T-SNEs just to reduce the dimensions from 300 to 2, and then we can plot it. And so in this case, we've selected a random sample of a variety of SNOMED CT concepts from ALS, epilepsy, Parkinson's, and you'll see that the sort of 50 nearest concepts to ALS are very close to the area of Parkinson's disease, and it's kind of what you expect, really, because they're both neurodegenerative disorders, and I guess epilepsy is a little bit further off over here as well. In the middle is your, apologies for that, is your stroke, and it's in between, and on the right-hand side is your heart failure. So there is a degree of learning that the models can produce or has the ability to produce from training from a large corpus after you sort of train these vector representations as well. Whereas if you look down here in separate clusters, which overlap to a degree, if you look at the nearest disorders relevant to influenza or your COVID-19 disorder, a lot of these tend to be pathogens overlapping as well, kind of representing that they both kind of relate and that they're very similar in this disease terminology or the semantic tag diseases. Fantastic. So that was mainly just for the nerds out there, but it's just I guess a visualization or demonstration that these models do learn not really about the disease itself, but the linguistics behind the disease. And I guess there is some debate whether, how we use disease in language, can that potentially, shed some light on potential correlations or insights into the actual mechanisms themselves through language, because I guess through language you can actually learn quite a lot, and that's the way how we communicate. But for all intents and purposes right now, this is just representing linguistic patterns between concepts and how similar they are used linguistically. And so now I've sort of set the scene for how we build a data lake and put all the data together. The next part is, well, okay, so what do we do? What does a typical NLP workflow look like in a hospital? And this is the sort of process that we've achieved that. And it starts with step one. And that's really to first of all define your cohort and retrieve your data set dependent on whichever question you're looking to answer. And so if you're looking to answer a question such as, how many patients have attend the neurology clinic, you don't need to take the entirety of the patient record to do that. You can just simply look at documents that have come out of that department. Same goes with A&E, or maybe you only want to look at adult patients, so above the age of 18, or maybe you want to look at pediatrics as well. And so based on this criteria, you want to almost very similar to how one does a literature review. You build a query and you cast your net that is broad enough to capture your data set of interest, but also small enough so that you're not wasting resources filtering out irrelevant patients and data. And of course, within CogStack, each document is related to or each of these rows contain metadata of a specific hospital record themselves. And this is where the unstructured part of the document is. And so, because I guess I'm sort of whizzing through this, there is a component that we do, and it's called MedCat Trainer. And this is a sort of process where we have clinicians engage, or these domain experts, to annotate the text according to your specific topic. And so this is what it sort of looks like from the front end. You're presented with a login panel, and if I go and just log in with a demo user, it logs in and you're presented with a variety of projects. And so for this user, there's only one open source data set, and this is from empty samples. And the task here is essentially to validate the performance of the model by marking various bits as correct or incorrect. And so in this case, there is no filter. So you're seeing a lot of gray, and each gray area here is a prediction from the model. So over here, it's recognizing CC as chief complaint from SNOMED. And it is the job of the annotator to then go through and label certain bits. So you press correct if it's correct. Does confusion mean clouded consciousness? Yes, it does. But in this case, if it's wrong, you can say incorrect. If it means something else, you can obviously highlight that portion of text, right click, and you can add a term where you can have a look for different concepts as well. And so in this case, there was a variety of examples. So if you were interested in that, this actually means stroke, you could search through and highlight the appropriate SNOMED CT term as well. If you knew what the appropriate SNOMED CT term as well is, you can, I don't know SNOMED CT or SCTID codes off my head, you can also add those codes as well to then label it as stroke and then add the term, and then it would recognize. So this is a way essentially of helping to produce an exam sheet, which the model is then benchmarked against to then check its performance, to first of all understand, well, is the current model good enough really, or is it not? And actually something I forgot to mention that is absolutely crucial before I go any further is the implementation for your annotators to have some sort of annotation guideline. And so this is something that we share with our annotators, and we produce an annotation guideline here. Fantastic. And then this is something that users can have a look at and read and understand what to do in certain contexts as well. And so you may notice that this is quite long, the annotation guideline. And the reason for that is because we found that actually doctors don't read the annotation guideline, and they tend to go back to it if they have an issue. So you kind of want to have it comprehensive enough that any troubles, they can obviously go back to it in the first instance before they ask a data analyst or someone who's in charge. Of course, going back to this, no project really is, no consultant or domain specialist is really asked to annotate the entirety of SNOMED CT at once to this document, because you can imagine in this single document, there is so many different examples, and speciality really ranges as well. And so these are all the various predictions. And so when a project is set up, there's a sort of admin panel, and which one can change the parameters of it as well. And so I'm just going to add a filter just to look for a specific SNOMED code, and then I'm just going to apply this to the document as well. And so I'm just going to refresh. And so this code that I highlighted was just migraine. And so if your project is, okay, within this document to only annotate migraines using SNOMED CT codes, well, it's very easy, right? Here, it's got a prediction, here, migraine, but still the annotator needs to go through and read through the text to highlight maybe manifested means headache or migraine, or maybe at some other point there is a headache example as well. But essentially, this is our sort of training platform where we are creating a labeled data set to train future AI models. Because once you produce a labeled data set, models change, as I said before, very rapidly, yearly, and architectures change. Google, Amazon, Facebook always produce something new, but I guess the ground truth doesn't really change. And so you're actually, as you label it, you're just learning from it as well. In this case, it does mean migraine, and we are accepting that. And let's pretend there's no other migraine process involved. We can then press submit. It gives you a sort of confirmation, and this tool uses an active learning process where you can then, it learns from it and then looks to identify other mentions of migraine as well, which in this case, I assume there is none. Anyway, back to the presentation. And so I've showed you how to add missing annotations, and there are ways you can also create your own, which would be extremely useful, right? Because depending on the project, sometimes, although SNOMED CT does have about 700,000 concepts, there are areas where it is deficient in, and one may need, depending on their own use case, to produce their own SNOMED CT concepts. Of course, there are meta annotations here as well, which one can then turn on. And the majority of ones that we use is these three, and these revolve around the patient, presence, and time. So experience are really relating to who had suffered from the concept, presence being, did they have it, did they not have it? And time being, is it relevant to this admission? Is it past medical history, or will it happen in the future as well? And so once you have a sort of trained or validated set, you can then run your model on your entire corpus of your relevant documents and label and extract relevant certain parts. Each annotation here does contain or hold a variety of metadata as well, such as where does it start in the document, where does it end, and the various metadata as well. So in this case, it's recognizing this misspelled word epilepsy as patient. They did not have epilepsy, the patient did not have epilepsy, and the patient does not have epilepsy now as well, because this can obviously change. So you mark it, it recognizes it on an individual label level. And of course, across a corpus of documents or documents for that patient, you can then start to build a nice picture of the health trajectory. And so from here, you can very easily and readily infer a degree of structure, and you then structure it based on your SNOMED CT hierarchy via the, I guess, ISA relationship. And all you need to do as a data analyst perspective is choose the top level parent concepts. So if you're interested in cancer, all other forms of malignant or tumor growth should be also counted under it. And in this case as well, epilepsy, juvenile myoclonic epilepsy, etc. And these can be as high level or as low level in the hierarchy as you want. And so this almost takes a lot of the complexity out from the analyst in having to understand whether generalized, whether a type of epilepsy belongs to epilepsy. That's probably a terrible example, but whether acute kidney failure belongs under renal disease or things like that as well. And so from the fourth step, final step, is really just your validation and to really bring it together with your structured data. And your structured data being a lot of the metadata. When did they attend? Which department did they attend? Are they an outpatient or an inpatient? Were they admitted? When did this happen? And the specific document ID as well. And you can piece it together with the now structured data set. And that's what we have looked to do. And that's how essentially the entire process. And so just a bit of an overview, and I probably should have, now retrospectively going through, probably would have started with this slide so it all builds as a bigger picture, where you have a data lake where your data comes from, and you capture or you define your cohort or corpus of documents that you're interested in. A subsample is then validated in the training step, where of course your document set may be 100,000 documents, and you don't need to annotate everything, and you want to automate as much of this process, but you still need to check whether this automation process is correct or wrong. And so this is a sort of concept level validation step, where your doctors or clinicians or stakeholders are interested in. You can then extract based on different levels of the hierarchy. And then there is actually something that's quite needed, is a second level of data validation. And this is really where, when you're delivering your output, well, what do the stakeholders really need or interpret, and does it match there? And sometimes this validation is already done through existing audits or clinical coding, previous clinical coding data sets as well. And clinical coding ICD-10, but SNOMED has a nice mapping to ICD-10, so you can do anything like that. But of course, sometimes it does require a manual subset validation to check whether this entire pipeline that one has built does actually work. So because a model may not be the thing that's mistaken in the pipeline of delivery, it could be the fact that maybe you've looked at the wrong clinic, maybe you've aggregated it incorrectly, maybe you've chosen the incorrect SNOMED CT hierarchy, or maybe even in that hierarchy, maybe there are terms that are irrelevant to what your use case is. And so this is how it works over here. Fantastic. And so just to have a brief look, I know we're running short on a little bit of time, but once you have this process of automation, one can very easily and rapidly annotate the entirety of a hospital's data. And so for a large hospital such as King's College Hospital or Guy's St. Thomas Hospital, without using GPUs, it takes about 4 or 5 days to annotate about 22 million documents with this technique. And of course, if you had a GPU acceleration, it could be a lot faster, or multi-processing as well. And so this is a sort of brief description of how one can potentially characterize your one's or the patient's data, and how now the information within each of these documents have almost been unlocked, and the iceberg, where they have a look at the ice using that analogy under the water, has really now been surfaced, and all this previously trapped data can then be used for any form of downstream analytics. And it's really, we're going through a process right now where we're getting a bit more creative in terms of how we use that data, and what sort of insights can you get from learning from patients that have used the system, and can we learn from their pre-collected data, and how do we apply it and optimize the experience for new patients coming into a hospital, whether it is through reducing waiting times or finding out optimal patient pathways, etc. as well. And so there's another link over here as well, which is just an example. Once you have in the same way how we did a concept embedding or representation of a concept, you can almost represent each patient as well with a vector or concept, or with a vector embedding or representation. And so if we just select a cluster of patients over here, you can see that in this cluster, it seems to be a bit related to your cardiovascular disorders or cerebrovascular as well. So it's a little bit of a mix. Whereas a cluster next to it is, I guess, something relevant for these, or characterization of these patients. Their top 5 SNOMED codes tend to be cardiovascular and hypertension. So a bit more cardiovascular here. If you go to another nearest one, there is quite close hypertension. And so you can see maybe we're going a bit more into the metabolic area. And so I'd probably expect a cluster near to that. Well, there you go. You've got diabetes and endocrine disorders as well. So you can almost characterize, and you can imagine how if you overlay this with your clinics or departments or your structure of one's hospital, you can look to potentially optimize the various services provided as well, based on, well, which patients are you seeing and what do they have as well. So I guess really quickly looking at the time and knowing that we're about to run out, there's of course a lot of potential feedback using this tools or these tools to SNOMED. And the first one being is that I guess in secondary care, not many clinicians are currently familiar with SNOMED. However, everyone's interested in data extraction, and whether it's for automating your audits or reducing workload or for research as well. And these types of techniques and automation and training models really helps clinicians learn a little bit more, one, about these ontologies, which they, I guess, in the future are looking to strive to use, and also about AI and machine learning as well. And obviously retrospectively looking at how well or how, how they populate these records for the future to make extraction tasks easier. Of course, these machine learning models learn a variety of synonyms and alternative words, and you can identify gaps in SNOMED CT as well and propose new concepts to SNOMED CT for real world use cases, because we are looking at real world data, and that's what the crucial part of it is. If there's something that doesn't represent a disease, and in this case it's malignant middle cerebral artery infarction, was one such concept which a clinician felt had to be a part of SNOMED CT. And then you can easily feed it back to SNOMED, and then there are SNOMED authors that can approve or disapprove. And so before, I think I've run out of time to go through several examples of demonstrations, but if there are no questions, we can certainly go through. But I'd just like to say that a lot of these tools are free and open source, and we try to build and formulate a community here. And so if you have any troubles trying to deploy it on your own laptop at home, whether it's a MacBook or something, feel free to, message us on our free chat discussion boards, or if you want to know a bit more about these systems, feel free to contact us at contact@cogstack.org for deployments. And of course, all these tools are open source within the Cogstack ecosystem. Just look on GitHub, everything is there. And so we try to be as transparent as possible with the limitations or not. But I know everyone's now talking about AI and machine learning in the field, but in reality, we shouldn't lose focus on the actual application, and because it's choosing the right tools to fit your use case or application, that's far more important than how one gets there. Cool. So thank you. I don't know if there are any questions, and if not, we can certainly, I just can jump into a variety of success stories about how we've potentially used this tool as well.
Thank you, Dr. Shek. While I want you to continue on, and I would love to hear those success stories, we do actually have some questions. So I promise not to fly through those questions because I do want to hear more. I really do want that to stop. Yeah. So we do have some questions. First one, of course, because SNOMED International, we are an international member-based organization, and SNOMED CT itself is used in over 70 countries, so it extends beyond English language. So you had to know that this one was going to come up. Harry is asking, is the model available for fine-tuning, in other words, in other languages than English?
Yeah. So a really good case is that a hospital in the Netherlands have produced their own Dutch model. And so I guess all the code and the information and structure to do it is all available. But I guess if it's not in English, you would need to edit some of the hyperparameters around it. I guess if the language is read left to right, it should relatively be straightforward. Of course, you shouldn't be using a SNOMED CT English edition if you're reading it in French, for example. If there is a French edition or release so that has French terms, feel free to use that, and probably edit it based on I guess variety of grammatical patterns. But of course, editing the parameters of a model here, just let us know that. But completely available as long as it's available in SNOMED CT. I guess in a way you could probably look to translate it, but translating medical terms aren't always the most optimal. So stick with if it's available in SNOMED CT. If there is an edition that is in your language, then and ideally left to right read rather than character based, such as I guess Chinese or Japanese. But although probably not impossible, but I have no experience with those right to left or character based or up down. processes. So if it's left to right, it should be relatively straightforward.
And yeah, good point. We do have a number of official translated international editions. So we have the Spanish edition, and we have most recently the Common French language edition, and then a number of our members in collaboration with others are also translating. And so we do have those various editions that could be utilized. So it could be a concept identifier, description-based, I guess, matchings and everything. So yeah. So the next question, how do you anticipate misspellings and ensure a misspelled free text code to the correct SNOMED CT concept, since there is a possibility of one free text that could codify up to 2 different concepts in different hierarchies?
So I think
how do you deal with misspellings?
Misspellings, right? So I guess you need to sort of look into the model a little bit. So whether it's acronyms or misspellings, it should be able to handle it. And I guess in a way, although not really considered a misspelling, a major problem that we had was that a lot of terms aren't just in British English, it's also in American English, and those two are very intertwined of spelling. So, and I'm sure there's loads of examples. One just can't. Okay, ischemic is a good one. Whether it's so in SNOMED it has an E, but in this example that I had, it has an AE as well. So this is a bit of a misspelling. And so part of the pipeline process, or part of this MedCat, it does have a vocabulary that it looks to. First of all, it looks to spell check against it, and in this case, it has a confidence of 1. So this very likely means that it didn't use any disambiguation terms here, but it used this idea of correcting the spelling first, and actually it's a direct match to ischemic. There wasn't any other terms it was confused with, and so this is why it was just a the model was like, okay, great, it must mean ischemic. Whether it was right or wrong is a different question, but it's confident irrespectively. Same thing, I guess, with MRI. You can consider that as a misspelling, or head MRI. So this is magnetic resonance imaging of head. And I don't know if this is, so SNOMED does provide synonyms, but not always. And so, for example, the model does need to sometimes learn a few things. And whether it learns or not, you can really improve that process through this MedCat trainer area as well. Fantastic.
Oh, lots of questions are coming in. Okay.
Okay.
Where have you had qualifiers such as true, false? Are you linking it to a pre-coordinated concept or using post-coordination?
Right. So yeah, good. Sorry, good question. And that is something I did not demonstrate, but this is where you do it on the trainer. And of course you can use any of these sort of qualifier values, but we felt like we needed to do it ourselves, and we need to make custom ones, because sometimes, and I think it's a problem that we found with SNOMED, is that sometimes you have history of epilepsy, history of Alzheimer's, but you don't have history of every single disease and symptom. And so it became quite challenging in that aspect. And so we have these sort of custom tasks that we produce, and these are completely customizable. And so if I just reset this, and I got rid of the filter, so you'll see a lot of predictions here. So if I label this as correct, yes, it is correct, because now I've added. Did I add the meta annotation tasks? Cool. And essentially, this is where you can label your various meta annotation tasks, and there should be a box that does pop up that you can label whether it's true, false, patient, or not, which is completely customizable. You can replicate it with your qualifier values, but you don't really want it to be too much. Let me just reset in this. This is why live demos are never great. So, okay, wakefulness, does it mean wakefulness? We're going to say yes, it does. And in this funny case, there is no appearance, but usually on the box on the right-hand side, there is these meta values. So if I just go back to my slides, I can demonstrate it over here, what it sort of looks like. And so a box appears as well. So this is what it would look like on the bottom right-hand side. It just happened on this demo, it didn't work, but it's funny enough because this isn't really a bug. But yeah, meta-annotation tasks, and you can label it accordingly. Obviously, you don't want to, there's so many different things conceptually you can capture, but we found that with these three and with these options, it is more than enough for any use case. Cool. Were there any other questions at all?
Yeah, I'm gonna skip down a few.
Okay.
One question that's come in: how does the granularity of concepts output from the cog stack compare to the manually coded concepts from clinicians' core problem list? With this technique, there seems to be an opportunity to use more granular concepts, which have more semantic value for analytics.
Yeah, so you can go as granular as one would want, and you can go as high level as one would want. So CogStack, it really looks for your key phrases. It doesn't really match a SNOMED CT term, but if you search for the word fit, it would retrieve all documents that contained the word fit. So whether that meant fit and well, or this patient's genes did not fit, or this patient with epilepsy had a tonic-clonic fit, it would retrieve all those documents. And so it's not ideal in that use case. Whereas MedCat, using SNOMED CT, fit isn't a primary name, and it isn't a, you would have seizure instead. And so it would look to understand whether fit does mean seizure. If you're interested in seizure, only extract, this patient has tonic-clonic seizure, and forget about the rest of the documents, even irrespective of the contain the word fit or not. And obviously, I guess what we try to do is we try to annotate or train the model to recognize the most granular SNOMED CT concept. So not just seizure or not, but whether it is a generalized seizure. And then if a patient, if the use case was to extract all mentions of seizure, if it said seizure or generalized seizure or different types of seizures or focal seizures or localized related seizures, it would be able to extract it, and you can aggregate it up using the inbuilt SNOMED ISA relationship.
Looking at the time, and we still have a number of questions, what I can do is get these questions over to Dr. Shek and contact info for any sort of follow-up. I will end with one question just because I think it's a good one to end on. We have someone who says that this is great technology that every digitalized hospital should be using. What do you personally see are the biggest barriers for this technology to become more widely used, and how do we tackle this?
The biggest barriers, I think it is one, educating the workforce and analysts and analytics, and two, the sort of the shift in the different areas where I guess a lot of the latest electronic patient record providers are shifting towards entering SNOMED as structured terms at point of input. And so you're essentially turning doctors into form fillers rather than easing the burden off them for the sake of analytics. And ideally, there is definitely some things that can definitely be structured. Smoking status or date of birth, but there are some things where we currently don't know much about, especially diseases or disorders, and terminologies change as well. Maybe diabetes isn't just 2 types of diabetes, maybe there's 7 types of diabetes that we find out in 10, 15 years. If you don't have a sort of clinical narrative that captures all the different features, you end up losing that bits of information, and you can't retrospectively go back and process it. Whereas with now, you can go back, whether SNOMED has a new release, you can go back and retrospectively deal with everything. So it really is, in terms of challenges, compute, IG permissions to deploy the compute as well, and storage. Yeah, those are the major hurdles that we are currently facing. And educating workforce, yeah.
Thank you for that. Thank you, Dr. Shek. Like I said, we have a number of other questions, but also I know we're a little over time, and I do like to try to be cognizant of people's time. So we will wrap this up for today. What I'll do is, so my email address is here, sro@snomed.org. And if anyone has any additional questions, go ahead and email me and I'll get those over to Dr. Shek. And yeah, I'd like to finish off by thank you so much, Anthony. That was an excellent presentation. And clearly the SNOMED CT community is very, very interested in your work. And I would absolutely love to have you present again in a future SNOMED CT webinar so that, yeah, we can get some follow-up to your work.
Absolutely. I know this was a brief taster today, but of course, any questions about more details, let me know, whether it's model or use cases or how we deploy. Very, very happy to always share and contribute towards an open science or open research, our healthcare community.
That's awesome. And I do see, just to give you a heads up, a couple of SNOMED international staff are also pinging me right now. So you'll be hearing from us very soon. Thank you. And to everyone who joined today, thank you so much. As I mentioned, these SNOMED research webinars are always recorded. So just give me a couple of days and these will be up on our YouTube channel. And yeah, and so thank you, everyone. Have a wonderful day.
Wonderful. Thanks.